Hello, my name is Louis, and this is a video about using the WPF to do 2D graphics. This is also my first online video ever, so hopefully it doesn't go too badly. The content of this video presentation, WPF offers three ways to draw in 2D: shape, drawing image, and the drawing context object. Shapes are controls that can be created directly in XAML. These have a lot of overhead, so they are relatively inefficient, but they are easy to use. The drawing image is the object-oriented entry point into the WPF vector drawing capabilities. So by object-oriented, I mean there are different layers inside WPF, and at each layer there are multiple objects that you can plug in. So we'll see what that means when I code the example for this drawing image. The drawing context is an object that also enables drawing in the WPF framework. It's much more procedural oriented than, say, the drawing image. By procedural oriented, I mean that while there are still objects, there is a lot less object layering inside the drawing context as compared with the drawing image object. The drawing context object itself has a number of drawing functions like draw rectangle and draw line. So in contrast, the drawing image object does not have a draw function. Okay, when you use the drawing image object, you create these layers underneath of that drawing image object, and then one of those underlying layers will have the draw functions. In WPF, every single control inherits from a class called the visual class, and the drawing context object actually draws directly into this visual class. So because the drawing context object is interacting directly with the controls of visual tree, the drawing context object is the most efficient way to draw in WPF. So that's basically the most efficient way to draw inside Windows without resorting to native coding. And lastly, I'll go over the brush object briefly. Like most modern libraries, the WPF 2D library is large and feature-rich. So it's not efficient to learn this big library or any other big library by going over every single feature. So for example, there are 6 brush objects, and I'll just go over the 2 easy ones. I think the most efficient way to learn this is to focus on the key features and the key concepts, as well as how to look things up via the IntelliSense and via MSDN. So looking up things online is very important, and I'll be demonstrating that in the examples. The shape class in the WPF, the shape is actually an abstract class, and there are 6 concrete classes as shown in the slide. I'll go over just 2 of those classes. The path class is actually the most general class out of these classes. The path class itself is sufficient to do everything. Rectangle, ellipse, line, these are just more specialized versions of the path class. Shapes are controls that you can embed into the program directly. To find out more about shapes, you have to type in one of the particular shapes, like rectangle. So you type in WPF rectangle, go to the MSDN page for rectangle. See, rectangle is a shape. So if you click on the parent of rectangle, which is shape, and then here you click more, they'll give you a list of shapes. So in this overview, I'll only cover path, and I'll also cover rectangle, and the other shapes are pretty similar to those two. To create a shape, to create a rectangle, you can just type in via XAML like this. So you type in rectangle. At the minimum, you need a height and a width and a fill. So height, say 100, width 100, width make it 200, and fill. Let's pick a color, aqua. So if you run this, you get the rectangle. You can give this a name, and then you can manipulate it in XAML. You can manipulate it when the window's loading, for example. Loaded, window loaded, event, navigate handler. So rectangle dot height is 100, and rectangle width is 100 dot fill. Now notice that fill is a brush. Okay, so that's one of the reasons that I switch over to the code, because in XAML everything's a string. It's almost like magic. So you have to do it in code to realize what these objects are. So fill is a brush. So whenever you see a brush, you can go brushes dot aqua. That, and you should see the same thing. Oh, well, it's a square. It's because of this. Okay, this is a rectangle. And there's a couple more properties. Let me see. There's a stroke. That stroke. Okay, so which is also a brush. So let's give it red. Stroke is the outline. Stroke thickness. What is stroke thickness? It's a double. Let's give 20 and see what happens. Okay, so you have this, red outline that's around the rectangle with 20. Now, because rectangle is like a control, so you have all the usual events. So you can actually do a mouse down, like a mouse down event. There. So this thing has basically hit testing. So message box I show rectangle got clicked. So this is mouse down. So rectangle got clicked. So that's the rectangle. Okay, the other object I want to cover is the path object. And so since we have two objects in the window, we're going to need a layout manager. So I'll put in the stack panel. So path. I'm going to do the whole construction of the path object in code. So I'm going to give it a name and construct the path object in code, because this one's relatively complicated. You could do the rectangle object entirely in XAML because it doesn't have all that much stuff here, but path has a bunch of stuff inside of it. So simple stuff first. I'm going to try to draw a rectangle. I'm trying to draw a triangle. Draw triangle. So that's the intention, to draw a triangle. Path dot. The easy stuff is path, like rectangle, has a fill. Okay, and like rectangle, path has a stroke. So the intention here is to draw a triangle that has an orange interior and a black outline. Okay, so the hard part is this: the path has a data object. So path is made out of the data of a path is a geometry object. Okay. So you can't really do this right now. I mean, you have to get a geometry object first. So go over to MSDN. So look for the WPF geometry, and look for geometry class. More. So here are all of the geometries you can use. So the geometry object is inside there's a rectangle geometry, but we're drawing a rectangle. We're drawing a triangle which is composed of 3 lines. So because you have 3 lines, you could use a geometry group, and then for each a geometry group basically contains multiple geometry objects. So you can use a geometry group, and then do a bunch of line geometries. I'm gonna use the path geometry. The path geometry is the most general geometry out of all these guys. Well, except of course for geometry group, which can contain anything. So I'll go for path geometry. Okay. So the path data is gonna point to a path geometry. So I'm gonna go to path geometry, PG. So I look at a constructor and see what does the path geometry need. Path geometry needs path figures, a fill, and a transform. A simpler version is just a bunch of figures. So I also I cannot construct the path geometry object right now because I need path figures. Path figure. So I'll put that. So I'll do a path figure, PF. Path figure. What's in the path figure? Well, path figure needs a start point, a bunch of line segments, a collection of line segments, and a close. Close means that, say, to draw a triangle, you only draw the first 2 lines of the triangle, and then you use a close. Set this equal to true, and the 3rd line of the triangle will be drawn for you automatically. So I'm going to use this. Just remember, you have to do the start. Right, start point equals new point. Say I can make it 100 because the rectangle on top of this thing is 100. And the close thing, right? The close thing. So this way I only have to draw 2 lines. And now the harder thing, segment thing. So segments, path requires a bunch of path figure dot segments. So, well, let's see if I can look up segments directly. Path segment collection. So look that up, right? Or you can click through this thing. Eventually get there. Oh. Just look at path figure, I guess. Easier. So there's a fields and properties. You want to click on properties. You don't want to click on fields. Fields is something else. Even though they sort of look like the same. You have 4 fields and 4 properties and they have the same name, but go for the properties. Segments property, right? That we're doing. This way you don't have to type in this. What a mouthful. Path segments collection. Just trying to collect. Yeah. So that's why I just click over there. Collection. So path segment objects. So here path segment. So you click on more. Path segment again has multiple childs and multiple children. So these are the segments. Because it's a triangle, I just use the line segment. But you can draw arcs and you can draw like some fancy curves. With this, but I'll just use a line segment. Line segment is why because triangle is just a straight line, so I can't really do this. Also, pf.segments. Let me write this down. Segments. I can't really do that yet. Well, I could do it directly. Yeah, there's nothing else underneath this. This is the final layer. Remember line segments. So start point. Now notice a line segment, there's only 1 point, okay? So what's happening here? Basically, this thing has a start point, right? over here. So that's why the line segment has only 1 point. It's gonna start at 100, comma 100. It starts 100, comma 100, and goes to this place wherever I want it to go. So new point. So because triangle, let's say x would be what, 0, but 200. How's that? So it starts at 100, 100, and goes to 200. Oops, I also need the stroke. Yeah, stroke just draw it actually. Oh, what else is wrong? Oh, I need more. Okay, so, and I need another segment. So let's just go 200, 200. So the triangle goes from 100, 100 to 0, 200 to 200, 200. So try to picture that in your head. And now with the path figure thing done, I can create this. Path geometry. Remember, path geometry can take the path figure. And then data, the path data is a geometry. So it's sort of like bottom-up coding. Oops, what's wrong here? Oh yeah, this is a bunch of them. Okay, so some mistake here. Oops. So here. So why is that? Okay, let me go back. So you can see that it doesn't take a single figure, it takes a collection of figures. So that's why I can't just stuff in the constructor directly, because it's a whole pg.figures. But how do you know that? How you know that? Look for on MSN. Path segment. Do I have path figure here? So path figure object. So path figure object, you look for properties, and so there we go. There's a segments property. So path geometry. PF path geometry. Did you mean path geometry? No, I mean the geometry. Oh man, this thing actually didn't show up. Okay, so that thing actually didn't show up in Google. So you select that, and you select this word here and press F1. So that's the that's the cheat. That's how you get there. So path geometry. So path geometry has bounds figures. Now you know it's called figures. So I pretend I don't know it's figures. Figures. New path figure collection. Actually, you can just call .add. And that'll be the path figure PF created here. So sort of space it out. Ultimately, you want the path data, but to get the path data, you need a path figure and geometry and so on, so on, so on. So let's run this. So you have the triangle. So the rectangle is like this. The triangle is like this. So the 100 and 100 is like this. See, the 0, 0 point is right around here. So if you want this big gap, let me get rid of that. Start point, I'll just get start at 0, 0. I think that's the default actually. So I don't actually need a start point if I use that. But just will show, oh, that's no good. What happened? Okay, so it went from 0, 0, 0, 200, so that's how you get that vertical line. Like the triangle before, so I'm gonna get 100, 100, 100, 0. So this will start with an x value of 100. So that's why this first point is over here, because it's 100 from the edge. And let's see, and notice that if I scale this, oh, it doesn't scale. Clips it. Yeah, okay. And like the rectangle, this path is like a control, so you have your your events. So let's try mouse down and see how good it is. Message box that show. Triangle got clicked. So you click in the rectangle, okay. You click inside triangle, you get that. Okay, that's expected. If you click on the edge, notice that if you click on the edge, you click right outside the triangle, you don't trigger that mouse down thing. Only clicks inside the triangle count. So this is so this thing does real hit testing. Later on, there's other methods of drawing, but they don't really do this kind of high-ended hit testing. They create a bounding rectangle around the shape, and anything inside that rectangle gets triggered as a hit test. So when those methods of drawing are used, the hit test, clicking here, right here, will generate a hit test. So this is a feature of when you're using shapes, you get the real hit test. So, and that concludes the coverage, the very quick overview of shapes. So now I'll talk about the drawing image. The drawing image is the entry point into the WPF object-oriented way of drawing vector drawings. So this slide shows the basic layering idea inside drawing image. So at the very top, you have a control. Like in the example, I'll use an image control. This image control will contain a drawing image object, and then inside the drawing image object, we're gonna have a geometry drawing object, and then inside the geometry drawing object, we're gonna have the geometry and the brush and the pen objects. So that's a basic hierarchy of objects shown in the slide. But it's actually more complicated than this because at the drawing layer, the geometry drawing is one of the options, but there are other options that you can plug into the drawing layer. So one of the options that you can plug in to the drawing layer is a drawing group object. So this drawing group object can contain multiple drawings. So effectively, the drawing layer expands out into a tree of drawing objects, and each of those drawing objects will contain a geometry, a brush, and a pen. And the same thing at the geometry level. At the geometry layer, one of the options that you can plug into a geometry object, one of those options is the geometry group. A geometry group object contains multiple geometry objects, and including other geometry group objects, right? So the geometry part of this diagram also expands out to be a tree. So just in general, in this approach to drawing stuff, you're creating a very large tree of drawing and geometry elements. And I'll show that in the example, in the following example. In this example, I'm going to instantiate a image control and then draw a rectangle and a triangle. So image control. Of course, there's a whole bunch of stuff inside. So name equals image. Window loaded event. Ooh. The window loaded event. That's where I'll do all my stuff. So the image control has about image has a source. So that's where the source of the image. So it's an image source. Okay, so I have to look that one up, right? What's an image source? So we press F1. Anyways, the image source over here. So as you can see, image source, there's a bitmap, there's a direct 3D thing, but the options you have for image source is, see, let me see. The options you have for image source is either a bitmap source or a drawing image, which is a vector. So this is bitmap, this is the vector. So and we're drawing triangle and rectangle, so the right one to use is the drawing image. So go back here, right? So the drawing image. That source. Okay, so let's look at this one, drawing image. What does it have, right? Well, it has a drawing. So drawing image has a drawing. So the inner object to drawing image is a drawing. Let's see what this one has. What's in the drawing? Okay, see, drawing is actually abstract, right? And so you have all these options for drawing. Drawing group is something that can hold other drawings. So image or video. So I'm drawing a rectangle and a triangle. So it'll be the geometry drawing, the vector-based drawing. Right, geometry drawing. Okay. So there's a geometry drawing thing here. And it's not drawing, right? And remember, the specific version of drawing that we're using is a geometry drawing. Oops, new geometry drawing. Okay, so the image.source is drawing image. Drawing image is geometry drawing. What's geometry drawing? Geometry drawing is geometry. Okay, so I get that. So geometry. So it's geometry. It's not that simple, of course. See, geometry is again an abstract. You can't really make a geometry. It's one of those. Now I'm drawing a rectangle and a triangle, so the rectangle is going to be this one. But there's two of them, right? There's two geometries. So it's actually geometry group. Okay. So this is, yeah, because I'm doing two. I'm doing rectangle and triangle. So this is not only geometry, it's geometry group. And then you're going to have a geometry called, yeah, geometry group is correct, yeah. And then you're going to have a geometry called rectangle, and then we'll have a geometry called triangle. Let's call rectangle first. Yeah, because previously I did rectangle first. Okay, so here it is. Okay, so look over one more time. Image.source is drawing image. Drawing image is geometry drawing. Geometry drawing equals new geometry drawing. Geometry. Oh, okay, so here we go. So this layer, the geometry drawing layer, has quite a few things. Has three things. In fact, if you see from constructor, let me do that again. Right, so this layer has a brush, a pen, and a geometry. So, oh, I still need it. So I just do it. So then a brush. That's the interior. So brush is orange. Geometry drawing that pen. So pen is a brush and a thickness, right? So brush is black. So black outline and thickness is like say 5 or something. And then this thing has a geometry. Just showing that geometry. This is the geometry group. Okay. So the geometry group then needs to be made out of 2 geometries, new geometry group. Okay. So let's go for geometry group. Okay, on the MSDN geometry group. Do I have geometry group? Oh, don't. Okay. Here's geometry group. So geometry group has children. So that's how the geometries are attached to the geometry group. So geometry group dot children dot add. So rectangle. And then also the triangle. Rectangle is there's actually a geometry for rectangle. So let me pretend I don't know what to type. Okay, I don't know what to type. So geometry. Oh wait, it's actually there already, isn't it? Okay, actually I already have it open here. So you see, geometry has a rectangle geometry and a path geometry, which I used in the shape example. Oops, go. So this is a new rectangle geometry. Oh boy. So this is just a new rectangle. And I use this one. So define rectangle by defining 2 points. So I guess this must be the upper left point. The first point that the rectangle must contain. Oh, it doesn't have to be the upper left, I guess. Oh, whatever. I'll make it upper left. 100, 0. New point. So 300. This makes the rectangle 200 wide. 100. So 100 tall. So the width is 100 to 300, and the height is 0 to 100. Do I need that? No, I don't need anything else. That's sufficient. I think that's sufficient. Triangle. This is set this triangle. This is the path geometry. Oh, oops, I don't want that. I want to use this. Take out geometry group. Path geometry, figures. No. Okay, figures. Do they have an example? Do they have an example? All this stuff. No example? Example? Sort of. Oh, that's sort of an example. Yeah, so this is how you read these sample examples. There's a path object that, and you point the path.data to path geometry. Inside the path geometry of a path.figure object. So this is just a hierarchy of objects. We're already on the geometry part, so this is path geometry. Okay. Actually, I should make this rectangle geometry. Yeah, so this is actually not simple geometry, it's a path geometry. Goes new path. Well, the constructor also gives you a hint, figures, right? Alright, collection of figures. So I'm gonna do it here. So how do you do that again? See, path figure. So you have a path figure thing. Dot figures. So path figure collection. So we really need a path figure. So can't do this right away. You have to do a path figure. What else do you take again? Figures. Path figure. PF triangle. path figure. So start point, bunch of segments, and closed. Okay, so PF start point. So PF, I'm gonna type in later so I don't forget. Is closed. True. And PF has a bunch of segments. So I should look at path figure. Yeah, if you don't remember what that thing is, it's called figures. Oh no, it's not. It's called segments. So this thing, PF triangle has a thing called segments. Goes segments collection. Okay. Okay, so start point triangle. This one's 100, 0, 300, 300. So I'll make it start like right there. So I'll make it start like 100. That's where the rectangle is, and 100. So path that segments, you do the dot add thing. So it's a collection of segments. So, and we already know this before. It's the line segment thing, but if you don't know, you sure look it up. It's just like in the shapes example, basically, and you get 1 point only. Okay, 0, 100. Let me fix the other part. No, it's not 0. It's 0, it's 200, because this is 100. Let me fix this. So 0 to 100, and then you do want to draw it. So is that it? Interesting. There, like that. Okay. So you want to add one more segment, 200, 200. It's a horizontal line. The second leg of the triangle is horizontal line. Path geometry, triangle geometry. So all this to get the triangle. This is a rectangle. Oh, let's see if it works. Oh boy. That's not encouraging. That's not good. It didn't really work, huh? I see. So I should separate this into separate. Yeah, because this is a separate layer. That's the path figure layer. This whole blob path figure. So I didn't add the path figure to the triangle. That's why when I run it, there's only the rectangle. There's no triangle. Figures that add PF triangle. Okay, let's do it again. So all this code. So notice that as I sort of resize the window, this thing is also changing size. So even though I gave the rectangle and the triangle like absolute coordinates, like 100, 100, well, these coordinates are relative to the image control. So what's happening right now is the image control itself is getting bigger or smaller as I resize the window. So let me lock the size of the image control. Oops, well, I want 400, right? Because the default is 350 here. Yeah, I want a 400, 400 image control. So now as I resize, this thing no longer grows and shrinks, although it still repositions itself because the image control is being automatically centered inside this window. Because in the absence of the layout manager, that's what it does. So but then this creates a problem here. Both the triangle and the rectangle there, they both have the same color. They're both orange. They both have that black border. Well, that's because the brush and the pen objects there attach at the drawing level. So the triangle and the the triangle and the rectangle, they're at the geometry level, right? Geometry rectangle, geometry triangle. So they have to share, the way it's coded right now, they have to share the same orange brush and orange that. So to make them different colors, we have to go back here and change a couple of things. So you look at geometry drawing. So you go geometry drawing. That's your drawing image. F1. See what options there are. Oh wait, it's actually open before already. Drawing image. That's a drawing. No, not that one. So it's geometry drawing. What are other options for geometry drawing? Drawing image, drawing. So we're using geometry drawing. We were using geometry drawing. There's also a drawing group which can contain multiple drawings. So that's a solution. You're gonna have a drawing group which itself contain 2 geometry drawings, and then each geometry drawing can then have their own separate colors. So here is, let's call this triangle or something. Okay, so let's call it geometry drawing 2. Should have done this. Geometry drawing 1. So we're going to have 2 geometry drawings. So the rectangle and the triangle. So rectangle, I'm going to make it aqua again, just like example 1. And the pen's going to be, the border's going to be red. Okay. I need a geometry group, right? I mean, excuse me, not geometry group, right? Drawing group. This one, drawing group. So I need a drawing group. Drawing group. New drawing group. So how do you add to a drawing group? Could be children, right? But we don't know. I don't know. Oh, it is children. Okay. Drawing group dot children dot add. Remember, geometry drawing 1, which is the rectangle, which will be the rectangle. It's not the rectangle yet, I guess. I haven't fixed it yet, right? Add 2. Okay. So, oops, and drawing group. So it's going to be this one. Okay. So image comes from drawing image. Drawing image comes from a drawing group. Drawing group has 2. Geometry drawing and geometry drawing 1, geometry drawing 2. So I have to make sure that 1 is actually the rectangle, right? And that's not true right now because of this. Okay, because this geometry group currently has both the rectangle and the triangle. So let's me fix that. So they have to be separate, right? So let's have the geometry group 1 and then like a geometry group 2 kind of thing. And then geometry group 1 is going to be the rectangle. Okay. Whew. What's going on? Oops, there we go. Okay, so drawing number 2, geometry drawing number 2 corresponds to geometry group number 2, which corresponds to the triangle. Geometry drawing number 1 corresponds to geometry group number 1, which corresponds to the rectangle. Okay. and the rectangle is created up here, and the triangle is created over here. Wow. Look, all this stuff just to draw a rectangle. Oh, let's see if it works. So the goal is to have a rectangle and a triangle, but this time the triangle will have a orange background and a black border, and the rectangle will have a aqua interior and a red border. And there we go. So the triangle, orange triangle, and aqua rectangle. So that's the example. That concludes this example. Oh, one more thing. This thing, when I'm using shapes, that thing had a hit test, right? So I could click here, it'll be outside outside of the triangle. If I click over here, it will be inside of the triangle. So one benefit to using shape is that there's, this is built-in hit test thing, and currently we don't have a hit test for that, right? The image control has a mouse down, so you can create a handler for that. And then, the mouse event has a GetPosition thing, so you can use this. You can use this to get coordinates relative to the image control. See, it returns your point, and the positioning is relative to the image control. Okay, but then you have to write your own code to know, am I clicking here or am I clicking here? The rectangle testing is of course trivial, that's no big deal. But previously the shape is able to determine if you're clicking outside or inside. But in this case, you will have to write something here to determine whether you're clicking outside of the triangle or inside of the triangle. So I think, yeah, okay, this will be the end of the example. Hello, now I'll go over the drawing context object. The drawing context object is yet another way to draw, and this one doesn't have much hierarchy versus the previous one, versus the drawing image object. The drawing image object, you have to create a bunch of things underneath it before you actually get to the actual draw functions. In this case, the drawing context class itself has a bunch of draw functions, so you can use it right away. There's less hierarchy. But one of the draw functions that are available, draw geometry, does involve hierarchy, because draw geometry will draw a geometry object, and geometry object is a hierarchy. It's a tree in general, as shown in the previous example. So other than that, this function is this class, drawing context class, this class is pretty straightforward to use. So drawing is the simple part in this picture. The more complex part is how do you actually display a drawing context object. And the concept here is hosting, that you can't just add the drawing context object to the main window. You'll have to create a control, a host control, and then you add your drawing context object. You get it from that control, or you add it to that control or something. So the hosting control, you have basically two approaches. You can do a custom control, but that involves doing style sheets. But then a custom control you can instantiate into XAML directly. The approach I use in the example is to use a derived control. So I just create my own class, and I derive from the canvas control basically. Once you have your control, either custom control or derived control, you have two options on how do you get the drawing context object. So option number one is the onRender function. OnRender is the redraw function for a control. So every WPF control will have this onRender function. So the system will call onRender whenever it needs to redraw the control. And inside onRender, inside this function, you're going to have the drawing context reference passed in to the function via some argument there. So that's one option. That's how you get the drawing context. But the problem with onRender is the number of redraws. Every time onRender is called, the control is basically erased clean. It's completely blank again. So you have to redraw everything. So in the example, I have like a triangle and a rectangle, right? So, and in this approach, every time I redraw, I have to draw both the triangle and rectangle. Suppose I only change the color of the triangle, I still have to redraw the rectangle because, like I said, every time on render is called, it's a complete erase. So to minimize the number of redraws, there's a second approach. That's why I use the second approach in general. In the second approach, you create these drawing visual objects. Now each drawing visual object will have a render open function, and this render open function returns a drawing context object. So you get your drawing context object by calling the render open function of a drawing visual object. And the other thing you have to do is you have to attach your drawing visual object to the control. And that's why we have these add visual child and add logical child. These functions refer to the data structure inside every single control. Every single WPF control, inside of it, they have a data structure called visual tree and the logical tree. So when you create your own drawing visual objects, you need to add your object. You need to register your object with those data structures inside. And the way you do it is by calling those add child functions that are listed in the slide. So, and in the following example slash demo, I'll go over both approaches on draw how to draw something via the drawing context interface. I will now demonstrate how to draw using the drawing context object. I'll draw a rectangle and a triangle using the drawing context object, and then I'll show how to render that object onto the screen. So to draw, say I have a function called draw rectangle, and I'm going to be using the drawing context DC to draw it. So this object drawing context has a bunch of draw functions, and there's a draw rectangle function. So oops, brushes the aqua pen. Be doing a black pen. And rectangle objects. So rectangle object takes 2 points. Oh, maybe I should using this one. You know what? Who cares? Yeah, point 1, point 2. 100, 0. Then new point 300, 100. And that's it for drawing the rectangle. Now function to draw the triangle. This is a little bit more complicated. Yeah, because there's no such thing as dc.draw triangle, right? There's a draw line. You could use that, I guess. I'm going to use the draw geometry, which is exactly the same thing I did a couple times already. So draw geometry, you have the brush and the geometry. Orange with a black outline. Right, so brush is that black. Now I need a geometry, okay? So I want a geometry. So I need to create a geometry object. So from previous experiences, it's the path geometry. There's a whole bunch of geometry objects, right? And one of them is the path geometry. Geometry goes new path geometry. Now path geometry requires a bunch of figures right here, figures. So dot figures dot add. We need to add a path figure. So I have to create a path figure now. Okay, path figure. So path figure takes a start point, a bunch of segments, and closed. Remember, close lets you draw a triangle using only 2 line segments. The computer will draw the final line segment. So remember the start point. So this is at the right under the triangle, right under the rectangle. Excuse me. Closed. Remember, this is the true. Figured out segments. You have to add 2 segments. The first segment, new line segment. Okay. So it goes from 100 to 0 to 100. Oh, it's right there. Is this right? Did I get it right? No. No. Something is more is here. This thing needs a new. Okay, did I get it right? Okay, looks like I got it right. So for the first segment is diagonally to the left. So it's from 100 to 0 to 100. And the second segment is like a horizontal line. Only the x value is changing compared to these two. Oh, the x value is changed. Okay. So that's the second segment. So that should be it. So I have a figure attached to a geometry. Attach a geometry to a draw geometry. Okay. Okay, so that's sort of quick demonstration of the drawing context object. Next is how do you display this on screen? You need to attach this to a visual, and every single control in WPF has a visual object embedded in it. So the strategy now is to find the simplest find the simplest control possible to minimize the amount of resource used, and then to attach this context to that control. So you have to create your own control. Let's call it class my canvas. Subclassing the canvas control. Wow. Why canvas? Well, canvas is the simplest, or one of the simplest controls. So public my canvas. I'll call the base here. I don't like this. Ooh. Okay, and yeah, I have to. This should really be in the canvas, obviously. Okay, so let's look at MSDN on the canvas. F1. So okay, so canvas. Oh, select this. Hey, it's not selecting this. It's selecting something else. Okay. Whoa. Oh, good. Yeah, I'm scrolling. Okay. So it's a canvas object, and like every object has a visual object deep inside this canvas object. So, when it's time to redraw the control, the WPF system is gonna call on render. Okay, so override on render. So you type override and then choose on render, right? Overriding this. So whenever the canvas, or actually whenever my canvas needs to redraw, the execution is gonna get here. So here I'm gonna go draw a rectangle, and notice this is where you get the drawing context. Draw a triangle, drawing context. Okay, so now I'm completed creating my own custom version of the canvas control. This control, when it runs, when it tries to draw itself, it's gonna draw those two, and those two will draw the rectangle and triangles. Okay, now to actually get this onto the form, so stack panel. So I'm not really using, stack panel. I'm gonna add it. I'm gonna add the control over here manually. So the main window is gonna have a instance of my canvas. My canvas. Okay. So, and then when the constructor runs, I'm gonna have the stack panel, right? Stack panel children dot add. Okay, I'm gonna add my canvas to it. So when this program runs, I'm gonna attach my canvas to it, and then Windows will redraw, will trigger on render, will draw the canvas, and then the triangle and rectangle will be drawn. Okay, so there it is. Here we go. Now the big weakness of this code is that in here, in onRender, both of them are drawn. And basically, if you look at the canvas object, there's something somewhere in there. There's a visual object somewhere in there, and drawing to a visual object is basically an all or nothing deal. If I change the color of the triangle, for example, that's my next step. If I change the color of the triangle, but the rectangle is still the same rectangle, right? I have to redraw the rectangle. I can't just say, oh, the rectangle is the same thing. I'll only redraw the triangle. Okay, no, if I don't call this function draw rectangle, it's not going to appear on screen. So if I only change the triangle, I still have to call draw rectangle in this implementation, because if I don't call it, the rectangle won't show up. So the solution is to create two visual objects, because right now this thing has only one visual child inside this control, because that's all they need. They only need one visual child. I'm gonna further customize this control so that it has two visual childs. Oh, by the way, visual is an abstract class. You can't really make a visual. See, visual's abstract. You have to do a container visual, and then if you want to draw to a drawing visual. So drawing visual is the class. So I'm gonna have two drawing visuals, and this is a generalization, right? DV list. Yeah, and of course, this is in real code, in a real program, this is gonna be more complicated than this. But I'm gonna have two drawing visuals. The first one is for the rectangle, and the second one is for the triangle, right? Just a comment to myself. That's the plan. Yeah, the reason here is this won't work because there's only one visual, and I'm drawing both of them. Yeah, if I have two visuals, I can just update only the one that I need to update. So, and we're not drawing to device context anymore. Okay, this function will actually join to the drawing visual. So using device context, not device context. Sorry, drawing context. Device context is from Win32, of course. Drawing context in DV list 0 render open. Yeah, render open. Okay. What's wrong with this? So they're redlining this. Guess maybe because I didn't initialize them. Well, I'll initialize them here. New drawing visual. Still doing that. Okay. Can't be it. Drawing. Oops. Equal sign. So okay, equal sign. So when I'm drawing a rectangle, I'm using the 0th drawing visual. And if I'm doing the triangle, get rid of this. This is hard-coded for now, but just for demonstration purposes only. So I'm drawing a triangle, I'm going to use visual number 1. The drawing context extracted from visual number 1. Again, for rectangle, it's visual number 0. So rectangle uses visual 0. Okay. Of course, in constructor, I have to draw it. Let's do that later. Draw rectangle, draw triangle. So in the constructor, I have to draw it. Okay, now this creates a drawing visual object, and then these two functions will draw into that object. But this still doesn't display on screen. To display on screen, you have to add this to the elements visual tree. So canvas is a control, and like every control has a visual tree. Okay, you add it to the visual tree the same way. Add visual child. Oh, well, actually, there's 2 of them. I can't use this. Okay, for each drawing visual dv in list. Oops, visual child dv. Okay. So when this thing starts up, I'm gonna add, the drawing visual object into the visual tree of the canvas. So that's one thing I have to do. That's not the whole story. Okay, I have to override this count thing. Get visual child count. Okay, get visual child. Get visual child and also get visual child count. They call it visual child count. So okay, so the platform is going to ask me how many child you have, right? How many visual childs you have, right? Because I know I call this, but how many do I have? I have a list, so I just returned the number of elements in that list. Oh, okay. Oops. So they're gonna ask me how many visual children you have. I'm gonna tell them elements list, and then they'll ask you, and then they'll try to retrieve the visual child. So override get visual child. Yeah. So this return dv list index. Right. So first I add it to the visual tree. I had to do all this, and then when I'm running it, they'll ask me how many visuals do I have. I have 2, so it's the number of visuals in this list. And then they'll ask me, they'll try to retrieve the visual, so I'll return the corresponding element in the list, and that should be it. F5 to run it so you see it. Okay, and the main point of all this is to redraw the triangle, without redrawing the rectangle, for example. So right now, the only place calling this is the constructor. The constructor is drawing the triangle, but if I make it public, then other people can draw a triangle too. And I'll make it so that the color changes. Okay, brush B. Right now, the color is hard-coded to be orange down here, so I'll do the B. Okay, so I'll draw triangle. I have to provide a color. So brush is orange. Okay. Now my plan is that when people click the mouse, I'm gonna change the color of the triangle. So mouse down. So when people click, they get here. And I'll choose a color. I guess I'll randomly pick a color. Random, new random, int rand equals. And to keep it simple, I'll choose between 2 colors. 0, 2. Wait, no, let's see. 0, 2. Okay, so 0 is the inclusive lower bound, so 0 will be returned, and 2 is the exclusive upper bound. So this thing will return 0 or 1. It will not return 2 because 2 is the exclusive upper bound. So just in case you don't know. Okay, so ran to 0. So brushes b equals null. If the random number is 0, b equals say pink. Okay. Else say b equals say yellow. Okay, so I randomly pick a brush. Oh, what's wrong now? Oh, peach. Okay, there we go. Hey, okay, the red line went away. Okay, then I'll call my canvas. I'll draw the triangle. Okay, I'll draw a triangle using the one of these two colors. And run, F5 to run. So the original color, of course, orange. I click, pink, yellow, pink, 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 yellow, 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 whatever. So, to prove that draw rectangle, this is only called one string constructor, by the way. So let's put a breakpoint here. So yeah, before it even pops up, it gets called. But that's the only time it gets called during constructor. So I do this, and this thing never gets called, right? I click, click, click. I'm changing the color of the triangle, but I'm not calling the code to redraw a rectangle. Now somebody must be redrawing a rectangle, right? If I'm going like this, right, the rectangle is completely gone. That means reappears. Okay, so the platform, the WPF or .NET or whoever, DirectX, whatever, somebody is drawing the rectangle, okay, but not this, not my code. So my code is as efficient as it can be because it doesn't draw a rectangle if I only have to draw a triangle, and that's the whole point of this exercise. And the other comments about the hit test, there is something to help you do the hit test, but I actually don't use it. So if you're interested, it's called Visual Tree Helper. Right, it's a helper class and has a hit test thing. So you can look it up. You can look up this hit test thing. I don't use it because if you use a hit test, I think by default it does a bounding rectangle hit test. So if you click here, you're clicking outside of the triangle, but that hit test will say that, oh, you're clicking on a triangle, because they generate this bounding rectangle around the triangle, and then you're clicking here, oh, you're in the bounding rectangle. Okay, so and that's not what I want anyways. I want the hit test to trigger only if it's inside the triangle. So you end up having to write your own hit test thing. So let's comment on the hit test. The other thing is scrolling. Like a lot of times you want to add scrolling to your drawings. So you do the scroll viewer here like this. But there's a trick in this case. Normally that would just work. This is all that's required to do the scrolling. Well, you need to make the horizontal scroll visible, because by default the horizontal scroll is not visible. Okay. Anyways, but normally this is all you need to do. But in this case, it's not going to work. Okay, of course. See, it doesn't work. There's no scrolling. This doesn't work, and there's no horizontal scroll bar. The reason it has to do with the canvas getting like a size of 0 or something. The canvas is not the right size, and the canvas doesn't respond to this thing correctly. Because I didn't exactly do a full custom control. I just inherited the class and wrote some code. So you have to do this. You have to give it an explicit size, basically. Now the triangle goes down to 200, right? So it's 210. And the rectangle, if you look, it goes all the way over to 300. So 310. Okay. So give it an explicit size. So now you get the scroll bar things that you expect to get. I'm going to put this down here. So you get the scroll bars they expect to get, because it requires this size thing. Okay, so this concludes my example. This is the last topic in my presentation, brushes. So here's in the slide here is the object composition diagram of the relevant objects. So the brush has a color object inside of it, and a brush also has a whole bunch of things. There's like 6 brushes, and some of the brushes are actually quite complicated. And a pen object has a brush object, plus it has thickness. It has a property that called thickness. And there's also some properties that let you draw dash lines, and they start with the word dash. So there's some dash xxx properties that let you draw dash lines. And the pen object also has some properties that affect how the lines are joined together. Hello, now I'll do an example about the color brush and pen. So I'll do a rectangle, name rectangle. Okay. So previously, I've been just using this, fill equals brushes, aqua or something. So let's run that. Actually see rectangle. Okay. So I should do a height and width thing so it doesn't fill the whole screen. Okay. Okay. So instead of brushes, I actually try to create a brush. Okay. So brush. Alright. Accepts a brush, right? So first, highlight brush, press F1. So brush class, brush is abstract, so you can't actually do a brush. Okay, so there are a couple brushes here. There's actually more brushes than this, but the simplest brush, the solid color brush. So it's just brush with just one color. So you can't do brush here, right? You have to do solid color brush. New solid brush color. Solid color brush needs a color. See here, color. So I don't have a color. So I'll do color. Color now. So I know it's like color. Okay, put a cursor over the cover. I put my cursor over the color. Color is a structure, as you can see here. So you don't have a constructor for that. You just have to do this. Again, red, green, blue, right? So R for red. So 255. Put cursor here. Well, okay, I'll do blue. Blue B. So now it comes out okay. So it's a byte, right? So the blue value, the B component of the color is a byte, so it's 0 to 255, and so I'll set to 255. So I'll run it. So I've declared color. I set red to 255, blue to 255. So I'll run it, and there's nothing. Okay, there's nothing because color is not simply just red, green, and blue anymore. Color is also there's also an alpha component here. So alpha against a byte. Now, because this number, all the numbers are defaulting to 0. So if you don't do this, if you don't do this, a equals 255, it's gonna be 0, and alpha being 0 means that it's transparent. So this will work. So it's a purplish thing. Okay, and next, I want to show that color, in addition to red, green, blue, and also alpha, color also has an alternative interface here. I'll show you. Right, so there's your blue, but and there's your red, but there's also this stuff: SC A, SC B, SC green, SC red. So this SC thing, this thing is a floating point, so it actually varies from 0 to 1. So I'll do this here, 0.5, okay? And I'll put a breakpoint here just to show you a point. So I'll run it. Oh gosh, can't do this. Huh, can't put 0.5. I have to put 0.5 F. So okay, shall I run it here? Delete some of the old watches. So color dot I'm changing the red, of course. So up to this point, okay, at this point color dot red is 255 because I have assigned 255 up here. So if I run a single step, so next step, so color red is 188. So I'm just saying that the red here, the R here, and the SCR is actually linked. So when you set one value, it affects the other value. There's only one value underneath. There's two interfaces. So there's one value underneath the two. And also it's not linear. Notice because 255, right, times 0.5, it's not 188. So those two values are linked and it's not a linear value, okay? It's not linear proportion. So I'll just run it now. Yeah, so there's less red now. See, I made the red 0.5, so there's more blue and less red, and so it's more bluish now. So that's it for color. Let's go back to brushes. Yeah, so I mentioned there are 6 brushes. Well, there's only 4 listed here. Okay, so that's because some of them have multiple options. So I'm click on gradient brush. Okay, so whatever the gradient brush. I don't need brush anymore. So gradient brush actually has 2 brush. So I'll do the easier one, linear gradient brush. That's the easier one. So I'll go back here. Now I'm done with the color. Don't be using that anymore. So instead of this, I'll put down a linear gradient brush. Okay, brush. It's nice to see the constructor and see what it requires. I actually won't be using, so there's a whole bunch of constructors. Whoa. Okay, so I'll use a simpler one, gradient stop. So gradient stop is a structure that tells you, where the gradient starts and stops. But in this case, let me just use the default for now. I'll set the properties one by one just to show what they are. So gradient brush has interpolation mode, property, gradient stop, mapping mode, spread. Okay, and the linear gradient brush has, in addition, start point, end point. So let me do start point, end point first. Brush dot start point. So this is a point. Now, this point is by default, it's using relative coordinates. So in relative coordinates, the x, y values, they vary from 0 to 1. So if I put 0 here, that means it's the leftmost value, the minimum value for x. So I'll start on the left side, and I'll start halfway down the rectangle. So again, just keep in mind these coordinates, they are relative coordinates relative to the rectangle, and they vary from 0 to 1. Okay, so when I run the example, you know what they are, what they mean. So my endpoint is going to be on the other side of the rectangle, so it's going to be 1. Okay, the x value is going to be 1. That's the opposite end of the rectangle. And 0.5. Okay, so that's one thing. So the linear gradient brush has start point, end point. Okay. The more general gradient brush has a gradient stop. Okay, so gradient stop is what tells you where your color starts and ends, basically. So I'll do a gradient stop here. Gradient stops, plural. So you do an add here. So I need a new gradient stop, right? New gradient stop. So gradient stop has a color. So that's So each gradient stop is composed of, well, so the default constructor doesn't do anything. Okay, each gradient stop has a color and a offset. It's like a location. So if I say brushes dot red comma 0, this means that, okay, this means that the it's going to be red at location 0. Again, this number is relative coordinates. So at the beginning, it's going to be red. Beginning of this brush. It's not that long, so I'll put it on the same line. And I'll add another gradient stop. Ooh, wait, this didn't work. Why? What's the error? Oh, it's not double. That didn't work. Oh, I see. Oh, I didn't look at careful enough. Okay, I'll go back. Mistake. Okay, so gradient stop requires a color. Okay, normally in WPF you don't need color. It's usually brushes. So I've been doing, just keep whenever I see color, I just type in brush. But this time when they are asking for color, they actually mean a color. So yeah, usually you type in brushes dot some color, right? So this time they actually really want a color. Okay, so red. Okay, so 0. Okay, this will work. So at 0 in the beginning of the brush, I'm gonna have red, and at the end of the brush, at location 1, I'm gonna have blue here. So we'll see. There we go. So in the beginning here, I have red, and at the very end, I have blue. Okay. Now, if I put down, these are relative coordinates, so if I put down 0.1 here, right, and then I put down 0.9 here, that means 10% of the way into this rectangle, I'm gonna have red, and the last 10%, I'm gonna have blue. So it's gonna stay red. It's gonna start red. It's gonna stay at red until it gets to the 10% mark, and then it's gonna turn into blue at the 90% mark, and then it's gonna stay blue. So we'll see. So here we go. So like right here, right? So the first 10% is red, and the last 10% is blue. So that's what gradient stop means. You pick a color, you pick where the transition occur. Now there's a bunch of other properties. Won't be using it. This one, color interpolation mode. Let me just show you that. You probably won't notice the difference unless you look really closely. Color interpolation mode equals, so they suggested this. So it's either that or this. Linear interpolation or S. So remember, this is the SC thing and this is the S thing. Remember when I did the color thing, when I did the color structure, there's that binary thing, the byte thing, and there's a floating point thing. So this is the floating point SC, whatever that means. Okay, that's the floating point one. This is the byte one. So supposedly the floating point is better because remember how it doesn't really scale linearly, right? So this okay. Okay, take a close look at that. Do it faster. I'll try the other one. Oh, okay. So in this one, this transition seems to be smaller, huh? I don't know. Okay, so it's just saying that supposedly that C is supposed to be smoother because it's using the floating point thing. So it has a more balanced transition, I guess. It's a wider transition. The other one, the transition seems to be kind of squished in the middle. So that could be important. That's how aesthetics you are. Okay, guys, it's right. Okay, gradient stop, cover that. Interpolation mode, I cover that. Oh, mapping mode. I'm using these things are relative coordinates. You can use mapping mode and make it like you have this absolute. I've been using relative to bounding box. That's the default. So, but you can make absolute coordinates if you want to. And let's see, spread method. Click on that. Hope they have a nice example here, maybe. Only some pictures. Yeah, it sort of tells you what to do. Oh, here we go. So reflect. So, okay. So this is step high. Okay, I'll put mouse over it. Okay, so in this one, so the gradient's like in the middle here. Spread method says like, what do I do here? So by default, it uses your color. So this thing transitioning from white to black. So in this part, it's doing it white, and this part is doing it black. So they call it the pad. And you have these other options. You can make it like this. So this part is not white. So it's sort of transition from white to black again. Okay, so I'll do this. Easy enough. So make it maybe 0.3, 0.7. Okay. So here we'll have 30% red, 30% blue, because I'm using the default spread method, which is pad, because I didn't define anything over here, right? I say 30%. At 30%, we're gonna go red. So what happens between 0 and 30%? I don't know. So computer just puts red here. So that's the default behavior. So I can override that using that that thing, spread thing, spread method equals gradient, spread method. So you hit enter. Here are your options. Pad is the default. I'm not gonna try that again. Reflect. It's gonna go red to blue. So I didn't do anything. Must be missing something. Let me take a look. So that appeared to not work because the start point and end point, it's 0 and 1, so that's pretty much held it. So let me change this again. Let me comment that out. Don't use spread method. Let me change this 0.3, 0.7. So I'm saying that, at 30% I'm gonna start the gradient, and at 70% I'm gonna end the gradient. Because what happened before was that the color didn't change because I was holding it at the end point. Okay, so 30% red. So 30%. Okay. So the new code, the previous code forced, start point of the previous code is like this, right? The gradient starts at 0 and it's gonna be red all the way up to 30%. So this thing didn't do anything. This spread method. But in this new code, I'm gonna have it sort of like this. So now the code is saying that at 30% I'll go red, and that's the start of the gradient. At 70% I'll go blue. So here's 70% blue, and the endpoint is the gradient is at 70%. So this code, this new code, doesn't say anything about what happens if it's between 0 and 30%, right? It doesn't say, because the gradient start point is at 30%. So this new code no longer enforce anything for the 0 to 30% range, and likewise it has an endpoint at 70%, so it's not going to enforce anything at the 70% to 100% range. So I'm gonna run it. So it's like this. Okay, so then the new gradient starting at 30% here, 0 here, but the very first 30% we don't the computer is padding it with red and it's padding with blue. So if I turn on the spread method, it's going to create a gradient. Yeah, so in this new code, the computer no longer pads the first one with a solid color, solid red, and it no longer pads the last 30% blue. So this time around, the computer is generating a new set of gradients. So how does it know what to do? Well, it's reflecting. The mode is reflect, right? So it's taking what's going on over here and it's reflecting over here. So that's a gradient reflection method. So that's a reflect. So I've gone over all of them. Oh, and one more thing. This gradient brush, there's two gradient brushes. Let me click on this class again. right? There's a radial gradient brush. I'm not gonna do an example on this. Just show you a picture what it does. This thing, radial gradient. See, radial gradient brush. Okay, this thing, if you can just look at the pictures. Go all the way down here. Okay. So instead of like some kind of linear gradient, it has a center point that's one color and has a radius another color. So it's transitioning from, in this case, from like white to like some kind of dark gray. The center point of some ellipse is white, and gradually transitioning to gray. So maybe they have more pictures. Oh, they have another one here. So yeah, so it is an ellipse. The previous picture makes it look like a circle, but yeah, you are defining an ellipse, and then you define the center to be one color, and then you define the edge of the ellipse to be another color, and the computer will kind of draw a gradient between the two. So that covers it. So there's a bunch of other brushes. Might as well go over them briefly. What other brushes are there, right? Gradient brush, bitmap brush, not that interesting. Yeah, the bitmap cache makes stuff go faster, but that's not really that useful. The tile brush lets you like draw things repeatedly. So let's click on them. Oh, there's a visual brush. Image brush. So this one lets you repeat images, I believe, right? So you have some picture like this, and you can repeat like a lot of times, right? So the image brush inheriting from the tile brush. The tile brush is what gives it the functionality to repeat things over and over again, and image brush means that it's repeating an image over and over again. So let's look at the other one. Tile brush has another children called drawing brush. And just go down here. Oh, missing. Okay, so see the other one, the image brush is repeating an image. This one is repeating a drawing. So this is actually a drawing. So they drew an X, drew a star, and they're repeating it. Okay, so that's it for brushes. Quick example. Last thing I go over is the pen. So I'm gonna do this again. Brushes dot yellow. Rectangle dot stroke. See, stroke is a brush. It's not a good example. Let me try something else. So anyways, I was hoping the stroke is a pen. Actually, the stroke is a brush. So I want to have a pen example, so I can't use this. I can't continue this example like as it is. So I'm gonna have to start over and use the geometry object, because that one is a pen. Okay, so I can get rid of this. Get rid of this here. So I'm gonna have an image, name image. Image source equals image source. Okay, image source. Image source. Okay, so F1 here. Oops. So I need a drawing image. New drawing image and requires a drawing. I don't have a drawing. I had a drawing now. Drawing. Okay. Well, no. New. Okay, let me go here. Drawing. Drawing's abstract. Geometry drawing. So geometry drawing here. Geometry drawing. equals a new. Alright, there we go. There we have the pen, right? See, brush, pen. So I'm not gonna do it here. Oh, let's do a default one. I want my rectangle geometry. Rectangle. So my rectangle. Right, drawing that geometry in the rectangle. I've gone over this before in the other tutorial. Rectangle. I'll use this new rect. 0.1, 0.2, I guess. New point. It's 0. Yeah, 0, 0, 0, 0. 100. 100, 0. What did I use before? 300, 100. Oops, there we go. So that's the rectangle. Drawing that brush. This is the interior, right? Aqua. Now we get to drawing that pen. New pen. So pen is taking a brush and a thickness. So pen is not simply just color and thickness. Pen is actually brush and thickness. So I kind of want to try that gradient border thing. Thickness, make it 20. So pretty, really obvious thickness. We don't have a brush. Was it linear gradient brush? Oh, I shouldn't have deleted all that. Oh, I should. I already typed all that. Which one do I use? I should try this one. Start color is brush style red. End color brush style blue. Let me try this. Oh, keep forgetting. When they say they want a color, they really want color. Right? They really want color. Color style red. Color style blue. And 0. See if this works. Ah, it works. Yeah, that's because the image object doesn't have a size. Let me fix that by a fix, not real fix. Stop growing with the window. There. At least now it's no longer growing with the window. Anyways, so there you go. This is a demonstration of a pen, and the reason that pen is not simply a color with a thickness. Pen's a brush that gives you more. You can do more. So here's an example of a rectangle with a border that's like a gradient. It's only made possible because the pen is taking in the brush object. Okay, so this concludes the example about color, brush, and pen.